Hello everyone, I'm Paul and today we're solving problem 2273. Find resultant array after removing anagrams. This is an easy one with different solutions, and here I will show you my thought process and code. We are given a string array words, so let's say we are given this. Here each word has lowercase English letters, and we need to compare adjacent elements. So let's say we are comparing this and this. We need to check if these are anagrams. In case you know what an anagram is, here we have the definition. It's a word or phrase formed by rearranging the letters of a different word or phrase. So if we can rearrange this somehow to get BCA, these two are anagrams. So now the question is, how can we check if two words are anagrams? And there are different strategies for this. One is we can sort both words and check if they are equal. This is already sorted, so after sorting we get the same, ABC, and here after sorting we get ABC. And given that these two are equal, these are anagrams. Now when we find two words that are anagrams, we need to remove words at I. This is I and this is I minus 1. Words at I corresponds to the word in the right, so we remove this. And there's another strategy to check if these are anagrams. We can build a frequency map for each word. And in case you know what a frequency map is, it's just a map with frequencies for unique characters. So we are iterating every character here. First we have an A, so we add A as a key with a count of 1. This means up to this moment we've seen character A only once. Next we are here, so we add B with a count of 1. Next here we add C with a count of 1. So this is the frequency map for this word, and we have frequency map 2 for this word, which is exactly the same. We have the exact same keys and values in both maps. We have 1B, 1A, and 1C. So these two are anagrams, so we remove the word in the right. And now the next question is, which words should we compare first? Maybe these two, or these two, or these two. What's the right approach here? And the answer is, it's the same. Because if we compare these two, we remove the word in the right, and then we compare these two, we remove the word in the right, and we reach the same result. If we compare these two, these are not anagrams, so we don't remove anything, and eventually we will compare these two, and we will remove this, then compare these two and remove this, so it's exactly the same. So if we have three different words and these are anagrams, well, if this and this are anagrams, we will remove this and then remove this. Now, if these and these are anagrams, but these and these are not anagrams, in this case we can't remove anything. Why? Well, because given that these two are not anagrams, we can't remove anything. And if these two are not anagrams, this means that these two are also not anagrams. So in this case, we don't remove anything. So with these concepts in mind, there are different possible solutions here. For example, we could compare these two. Given that they are anagrams, we can remove this or replace this with an asterisk, and then we can filter every asterisk from the array, so the new array will include these three elements, and we can loop this again and loop this again and loop this again until we don't have any more anagrams. Or we can do the following. Let's say we only have one word. In this case, we don't meet the conditions for an anagram, so we just return an array with the only word we have. So we can create an array result which has the first word initially, this word. We can just iterate this from left to right from index 1 from here, so here is the I pointer, and we are checking if these and these are anagrams. given that they are anagrams, we just continue. Now we are here and we are checking if this and this are anagrams. And you might be thinking that this is not correct because we have just removed this word. The thing is, we removed this because this and this were anagrams. So if we compare this and this, it's as if we were comparing this and this. Okay, so this is the trick. We always compare the current word with the previous word. In this case, these two are anagrams, so this is as if we remove this one and we continue. Now the I pointer is here and we are checking if these two words are anagrams. And remember, this is as if. We don't have this, we don't have this, and we have ABC here, and we are comparing ABC and A. Okay, so it's exactly the same because these three words are all anagrams. Okay, so given that these and these are not anagrams, we add this here to the result. Now we reach the end and we can return this array. So with this in mind, let's go with the code. As I said first, there are different solutions for this. So here we will pre-compute the frequency map for a reward, and then we will iterate, compare, and get the result. So here we can have a map of counters. We will call this C. This is an empty map. And we can say for I in range n, counters at I is counter from words at I. So now we have all the frequency maps here and we can move to the next step. The result is an array with the first word, words at 0, and for I in range from 1 to n, if counters at I is different from counters at I minus 1, we add to the result words at I. And finally we return result. So this is the entire code, and this is only one possible solution. So let's submit this and see if it works. As you can see, this works and it's very efficient. Here, time complexity will be the amount of total characters in words, and space complexity big O of n, where n is the amount of words, and this is because we can have up to 26 characters for every counter, and this means counter requires a total space complexity of big O of 1. So that's overall big O of n space complexity. And you could try to make this more efficient. For example, you could replace this counter with an array of frequencies, and that might be more efficient. But I will leave that to you. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.